Hello, my name is Aaron Cantu. I'm part of the ECE team Kernel NANDers, and our project is Soteria's Brace. Our mentor is Dr. Patrick Benavides, and we were sponsored by Texas Hamburger Company and William Cantu's Allstate Insurance Agency. I was the lead creative and aesthetic designer. I helped designing the program, prototype, circuit, and helped construct the prototype.
Hi, I'm Hugo Menendez, and I'm the project manager for Soteria's Brace. I oversaw every aspect of design, including programming and hardware.
Hi, my name is Devin Neal. I was responsible for 3D modeling, building the hardware, as well as circuit debugging.
My name is Fabricio Zuniga, and I'm the documentation lead, where I focus on keeping track of the budget, developing the original remote control interface, and assisting with debugging with 3D modeling.
So, Soteria's Brace is a robotic smart brace. Its main purpose is to provide an extra layer of home defense at the front door. Some problems with the manual door braces are you can't arm when leaving, you aren't notified if someone's trying to break in. Current problems with smart braces are they require you to install manually and they cannot be moved once installed. This leads to our goals for the product. We wanted to provide a convenient and effective smart brace, something easy to use for different ages. No installations, a way to activate and deactivate remotely, and the ability to link your smart devices to the product. And the next slide, we'll be demonstrating our initial design, which our 3D designer Devin will be discussing with y'all.
It was inspired by a Masterlock door brace as seen at the far right. As you can see from the initial design, we wanted a 3D printed case. The cost to print the entire design would be out of budget, so we went with birchwood with metal instead. Internally, we have 3D printed mounts to properly secure the components. A 3D printed telescoping arm is used to conceal the wire of a push button. We used a Lexan sheet as a lid to protect the components. Here are the important components that were used in the build of this project. The Opti isolator for handling back EMF, Roomba wheels for movement, linear actuator for bracing the doorknob, H bridges for switching input voltage polarity, shock sensor to detect hits. The NanoPi was the main component and control the I/O of the system. Hugo will take it from here to discuss the design schematic.
Thank you, Devin. Here we have the design schematic that gives a detailed overview of how the components are wired in the system. The NanoPi Duo 2 is the main component that controls how the system operates by sending and receiving signals to and from each major component. It is powered by a rechargeable 5-volt power bank and it is interfaced through PuTTY via an SSH connection. Aside from the NanoPi, most other components are powered through a rechargeable 12-volt lead-acid battery. The NanoPi's GPIO output pins are fed through to opto isolators, which then connect to two H bridges. These opto isolators are powered by stepping the 12-volt battery's voltage down to 5 volts by using a buck converter. The top H bridge is powered by boosting the 12 volts to 14 volts because the desired voltage across the Roomba wheels is 12 volts, and the H bridges have a 2-volt drop across them. The H bridges control the direction of motion from both the Roomba wheel modules and linear actuator, which is determined by the digital output pins from the NanoPi. The actuator will continue to extend itself until the push button shown at the right of the schematic is pushed, which happens when it reaches the doorknob. The shock sensor is used to determine when Soteria's brace is in place and when there is an intruder detected. Lastly, the LED is used just to indicate to the user that the device is working as it should. Here we have the software flow diagram. We start at the top there and check to see if the power is on. If it is, the NanoPi will turn on the power LED and then wait for user input. The user would connect to the server that is being run with Django by using their web browser. They can set the function they want to run by appending the URL with their desired function. These functions include arming and disarming the device as well as an emergency stop command. If the user chooses to arm the device, then the right path is taken, which includes moving forward, stopping when the vibration sensor detects the door, extending the actuator until the doorknob is met, and then setting itself on standby with the shock sensor. If the shock sensor detects a hit, it will push the Roomba wheels forward for a few seconds. Now, if the disarm function is selected, the left path is taken and everything is done essentially in reverse, and then the device stops. Next, we'll have Fabricio go over the cost of design.
Thank you, Hugo. Here is the cost and budget that was accumulated throughout the semester. You see the products are partitioned into two groups. Above are the items bought for building the project, with columns detailing price and quantity. At the end, you see the totals before and after shipping with handling. With additional expenses, as in the parts bought but not used, a new total is calculated as shown in the bottom. Here, we'll have our video demonstration. Note that some parts were sped up to save time.
So this is the interface. Basically, we have Django running a server here. And then we have a client here that that connects to the server via this URL. It has the web arm function, and this also works on a browser. And then depending on the function that we want, we'll change the URL. It's spinning. Try to open it. Try to open it.
The key takeaways from the project were time management, adapting to issues quickly, and communicating effectively. We also gained valuable experience using Python and 3D modeling. I will pass it to Fabrizio to go over the acknowledgments.
Thank you, Devin. We would like to thank Dr. Patrick Benavides for guidance on developing the project and the machine shop for helping with cutting wood. Thank you to Texas Hamburger Company and William Cantu's Allstate Insurance for sponsoring our project. Finally, our updated Design 2 poster. You can check our poster on the UTSA Tech Symposium website. We included a video on the door brace in operation in the poster as well. Any questions?